Hi everyone, I'm here to do LeetCode problem number 239, sliding window maximum, which is a hard problem. You are given an array of integers, nums. There is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see the k numbers in the window each time the sliding window moves right by one position. Return the max sliding window. So what's going on in this problem is that you're given an array of integers and you're given k equals 3, which is the size of the sliding window, and you're moving the sliding window across the input array, and each time you move the sliding window, you want to parse and grab the maximum value within the current sliding window. So right now this is 3, 3, 5, 5, 6, and 7, and then the answer is the per each sliding window you grab the maximum and return an array with all the values that were maximums. So essentially you want to go through the, let me say that one more time to be clear. You have a sliding window that slides across the input array multiple times from the beginning to the end, and each time that the sliding window moves, you extract the maximum value within the sliding window, put all those into a new array, and then return the answer. And obviously if there's only if the sliding window is of size 1 and there's only a number within the input array, then you return an answer of 1. This is a sliding window problem. It's tricky, but it's also not hard. So let's do it. So here are the constraints. 1 is less than or equal to nums.length, which is less than or equal to 10 to the 5th. So this is telling you that the length of the array can be as low as 1, but also as high as 10 to the 5th, with 10 to the 5th being a very large number. This is saying that the actual values themselves within the input array can be as low as negative 10 to the 4th and as high as 10 to the 4th. And obviously we have this last condition right here, which basically says that the length of the sliding window can be as low as 1, but also as high as the size of the array itself. And this is important in the sense that we know what the brute force solution is, right? You move the sliding window along the input array and do like a for loop computation or some kind of calculation within the sliding window each time to find the maximum value within that particular sliding window, and then you slide it to the right, and then you slide it to the right, and keep doing that same computation. But we know that the length of the array can get pretty unwieldy, as well as the length of the sliding window itself can get pretty unwieldy, pretty extreme. So for those reasons, we're going to rule out the brute force approach, the moving the sliding window and then going within each window to extract the value. That's just untenable. So we're going to have to be a bit smarter, and so I'll devise an algorithm soon. But let's take a look at the topic. This is obviously a sliding window. And let's take a look at some of these other topics that we're dealing with. This is a problem. So what do we have? This is an array Q, sliding window, heap, priority queue, as well as monotonic stack problem. Monotonic queue problem. So this is an array queue, sliding window, heap, priority queue, or monotonic queue problem. And so let's design an algorithm. Define a variable right that marks the right hand side of the sliding window. Okay, so then define an array of the correct size to hold all the answers. We're gonna call it, we'll call it res. Define a deck, a queue called deck that will serve as a monotonic decreasing queue. So essentially what we're doing is we're defining the basis of the solution is a monotonic decreasing queue, where the queue will store indices to the values in nums, and it's going to be ordered such that the maximum value within a particular sliding window, that index is going to be stored on the left hand side of the queue, the leftmost element of the queue. And so in this way, we're going to always have a monotonically decreasing queue, and the queue will not store the values themselves, but their indexes. And this is very important. We're going to use this to basically grab the max value within any particular sliding window, and then we're gonna use this deck to basically process all the sliding windows. That's what we're gonna do. Okay, and we also need a variable. We're also gonna do a. So now we're gonna do two steps. Define a for loop that will process all the elements in the first sliding window, but not the last value in the first sliding window. So we're going to define a for loop. Let's say for this example, we're going to define a processing logic that will process 1 and 3, but leave -1. And then this will be the cutoff that we're going to then use to loop from here to the end of the loop, from here to the end of the loop to process all the other sliding windows, right? And then we're going to define another for loop that will process all the other sliding windows. So what do we need to do to process each sliding window? We need to define logic to maintain the monotonic decreasing queue. We also need to process the left hand side of the sliding window, because as we're moving the sliding window towards the right, we need to pop the indices off off the queue where we no longer need it. You know, for as let's say for this sliding window, we move it one to the right. Let's say this was a maximum value. We probably wouldn't need that anymore. We only want to be looking at the current sliding window and not anything that's out of bounds. And add the current maximum in the sliding window to the res array. Okay, let's start doing it. N equals nums right equals n minus k plus 1, right? Because this is the correct logic. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 3 is 5 plus 1 is 6, which is the size of the output, right? 1, 2, 3, 4, 5, 6. So that's the correct length, and we're going to populate all of those with zeros for now. And then we're going to do a dec. And then we're going to do a variable. Let me take a look. Define a variable, correct size, res. Oh, we're going to call this res. So that's res, but left is going to actually be, not left, right is actually going to be k minus 1. Because the array is 0 index, we're going to do right equals k minus 1. So now let's do it. For I in range 0 to right, this is the logic, val equals nums I if dec and nums dec minus 1 less than val, then dec dot pop, right? Well, this is what we're going to use to maintain the monotonically decreasing queue. So if not if, while as we've encountered a new variable that's the max, that's bigger than the values in the dec, so we just pop them off from the right until you know this max variable is the one that's the leftmost. This value is the leftmost value, right? So then we do dec dot append I. Okay. For I in range right to n, we're gonna do the same logic. We're going to add a piece of logic that basically says define process the left hand side of the queue, right? Process the left hand side. We're going to do left equals I minus the I minus right. Then we're going to do while dec of 0 is less than left, dec dot pop 0, right? And then what we're gonna do is we need to do res. We're gonna populate the result, right? Res of left equals nums dec 0. Of course, we have to return the result. Res return the result. Let's take a look if we did it right. Okay, good. Awesome. We did it. So this is a TC, time complexity is O of n. because we're looping through, the values each one time. And the space complexity is O of K, because the deck that we use to maintain the monotonically decreasing queue, that will always be, you're always going to be popping in appending values from the left. You're going to always be popping values from the right, as well as appending values from the right, as well as you're popping values from the left. And those are all O of 1 operations, but generally speaking, as you're moving the sliding window along, the space complexity should always be most likely in the average case. In the worst case, actually, the worst case is always going to be the size of the sliding window, okay? So this is my solution that I've been working on, and this was challenging, but I enjoyed doing it, and I'll see you at the next one. Thank you.